Hey class, good evening. Hope you guys are doing well. I have a couple of students reach out and ask about Lab 3, so I just want to use this opportunity to walk you guys through it a little bit more. So first of all, a lot of you guys already gave me something similar to this. Right? I will continue to use student and school just to illustrate this example and how we are going to normalize their entity. So, okay, hopefully by now you know this is an entity and this is another entity. For entity, you have to define some attribute, right? So let's just say address, let's say phone, right? And let's say name. This can be first name and last name, don't matter, name, right? All of these would be attribute and yeah, sorry, my speed is kind of slow today. I don't have a mouse with me, my mouse dead, so I'm using the laptop mouse. So all of these are entity, okay? You guys should know this by now, right? So similarly for school, you can have the same entity as well because you need to know the address of the school, right? You need to know the name of the school. You need to know the phone number of the school. So once again, this is attribute, right? And school and student has the relationship such that a student would go to school. Okay, so for relationship modeling, you need to use this box, the diamond box goes to. So student go to school. Some of you use whatever box you want to use, which for me personally, I don't care as long as you get your point across. But once you in a real world setting, you might want to use the right boxes just so that people know you know your stuff. Otherwise, it will seem like you don't know your stuff and you're just guessing. Alright, so first thing first, what you want to do is convert this into a table or into an Excel format. What I went ahead and did just to save some time is if you look here, this Excel format has most of the attribute that I define over there. Oh, yeah, okay. I didn't have school major, but let me just write down here. Major, like what are all the major the student can study in, right? Right. So take a look again. This is the ER diagram. Okay. When you convert to table, a lot of time what people do is they just make one table with all of those attributes. You have attribute from student, student name, student address, phone numbers, student age, school address, school phone, school major, right? So now, based on this, let's just go ahead and use Nick as an example. Nick makeup, right? School name is obviously KSU. Student address is 1111 somewhere on Earth. 11223 as the zip the state first, right? So Atlanta, Georgia, 13211, 13222 as the zip code. And then somehow we also have phone number here. I made this up purposefully just so I can show you guys how normalization works. Okay, so phone number that 447111100. Okay, this is a makeup phone number. Okay, don't be calling this number. I'm not sure whose number this is. This is I just make it up. Student age 18, school address once again 222 somewhere here, obviously Kennesaw, Georgia, right? And then I don't know the zip code. I'm just gonna say 66666. And then you have school phone. I don't know our school phone, so I'm just gonna put 11111. School major, let's just say biology. chemistry, computer science, software engineer, whatever. Okay, right? You see that this is ER diagram, entity relationship diagram, where you just have the entity, which is the student with all those attributes, and the student entity is linked together to the school entity, and these are the school attributes. The way this data look, right? You going from drawing diagram to actually looking at data now would be something like this. This entire first row would be what they call column. This is one column. Student name is a column. School name is a column. Student address, phone number is a column. Student age, school address, right? Because that's essentially what each of your attribute is. Each of your attribute would become a column in an actual table. Right? So that's what you see here. And this relationship is what you use to link student and school together. And in this case, because I only have one table, I go ahead and put student as well as the school together. So when you look at this data, you see that, hey, student nick makeup, go to KSU, and this is the student address and the phone number, student age, school address, school phone, and this is all the school major. Okay. All right. So first of all, you need to, after you have this, change it to first normalization form. Normalization is really, think of it in terms of ensuring that you can break up all of the relationship currently defined by this record into a more optimal way of storing data in a database. The reason why I say this is because if you have another student, right, then you have to enter another role, which sometimes is okay, but you're gonna have to keep maintaining Excel sheet like this. In a database format, you would break them into appropriate table and store them so that you can write SQL query and get the data back. So normalization is a way to optimize how data will be segregated or separated into dedicated tables in your database. Okay, so first normalization form usually mean that um, you want to ensure that you have a column that can uniquely identify the main record of your data. Okay, so I give you one example. When you first look at this, the first thing you do is if you see any attributes, if you see any columns with more than one attribute being converted, you would want to break this out into two separate columns. So in this case, first normalization form, right? This is just the first step. This is not the complete step, okay? So this is still first normalization form. Oh, didn't copy correctly. Alright, copy, paste, okay? And what you would do is you would take this phone number out. You would put it into a new column, right? And I'm just gonna put it here, which is fine. I'm gonna call student phone number, okay? And let me copy all of this and paste it down here. Okay, in this phone number, copy this, move it down here. 1222232. Okay. Alright, so that's the first thing you can do in order to do your first normalization. Any column that have more than one attribute in it, you want to break them out so that each column represent exactly one attribute. Okay, and now the next thing you should do is, alright, so I have all of these. Do I have anything uniquely identify the record? And if you look here, right, all of this data focus on the student, but there is nothing unique that could identify this record. One example is what happened if I have another student whose name is also Nick Maker because people names can be repeated. You have a lot of I'm sorry, right? I'm sorry if anyone named Charles, but you have a lot of Charles. You have a lot of Bill. You have a lot of Williams, right? Sometimes the last name also collide, right? You have people with the same first name and last name. So in this case, let's just say this Nick makeup student actually live on 5555 somewhere on Earth, not 1111 somewhere on Earth. Student also happen to be 18 years old. School phone is the same. Student phone number would be something different. 770 000 9999. All right. So now, if I have two of these records, what column can I use to uniquely identify or differentiate Nick makeup on row 9 compared to Nick makeup on row 10? Nothing. Nothing, right? Because if I use the name is repeated. If I use the address, that's fine, but does this address uniquely identify Nick makeup? The main entity we're trying to say is the student, so this field doesn't mean anything. I can use the school, but if I use the school, it doesn't uniquely identify the student. It just identifies the school, right? So this is where in a lot of database system, what they do is they introduce a makeup column known as ID. Okay, so what they do is in here. Okay. Move it here. Okay, and then let me just delete those space. I don't like to have blank space. Here I would now say student ID, right? And I'm just gonna, but each of you do have a unique student ID. What I would do now is I would put ID, let's just say 11111, let's just say 111222, and this alternate would be 222111. Okay, so now what I just did was first I remove column that have multiple attributes, student address and phone number, into separate columns. Secondly, I look at my data and I want to create an ID field that can uniquely identify the record, each that can uniquely identify each record in this data set. Right? I have two Nick makeup. They are two different people, but they just have the same name. So what I do is I create an ID column, and this ID column will be my primary key. And I'm just gonna highlight it, make it in bold, and underline it so that you know this is primary key. Let me go ahead and just put PK primary key. Okay, this is it, folks. This is how you do first normalization. You look at your data, you look at the ER diagram, first ER diagram, convert to this data, and then you do your normalization. Hey, are there any attributes or more than one attribute in the same column? If it is, have different column represent them. Hey, if I don't have anything that can uniquely identify the record so that I can make that field my primary key, then go ahead and create the primary key myself by giving it a random ID. Right? Random ID as in randomly generated number, and use that as your ID. So we just went from this data without any normalization through first normalization form by identify if there are any attributes in the same column. We break them out apart and then identify the primary key for these records. Okay, that's first normalization. Second normalization form. Okay, what does it do? So second normalization form essentially means for this primary key, is all data depend on it. So if I look at this primary key, student ID is a primary key, but this student ID because it clearly says student ID, it will only uniquely identify the student, which means what happened if I have school name, school school name is not uniquely identified by the student ID primary key, right? Same thing for school address and school major, right? Because this primary key once again only represents the student. It does not represent the school or anything school related. What you want to do is very basic and simple. This second normalization form usually associate with the activity known as identifying your foreign key. Foreign key, and I show you what it means. Right. So first of all, what I would do first is looking at all my data now. Right. I have all of this. Let me copy it, and let me first do this. Just imagine I call this table student. Okay. And this is still table student. Let me just highlight it. This is still table student. What I do is I will break this into two different tables. I will have table student still, right? But my table student will only have column that represent the student, which means school name right here. Right, I'm gonna move it out here. Student address, student age, school address, school phone, school major. I would first identify which column or attribute does not uniquely be associated with this primary key. And after I move everything, right, what I have identified left is, hey, all of the school stuff isn't needed for this at all. And if I move all of the school stuff out, now my data look like this. My table student went from having 1, 2, 3, 4, 5, 6, 7, initially 7 column, to 8 column because I break this column out to two different columns so that I can store student address and phone number separately. So 1, 2, 3, 4, 5, 6, 7, 8, right? Then from 8 column, it went to 9 column because I introduced a primary key column in here. So now my table has 9 columns from the initial 7. Second normalization form is essentially grouping only the similar stuff together, meaning any attribute that truly being defined by this primary key, I would want to keep them together. And when I do this, I break this out now to two tables, table student and table school. Okay, this is now my table school. Okay, so first of all, if I break it out like this, what attribute in here in the newly created table school can uniquely identify the school? Nothing. Nothing. Right? School address, sure, you can use that. It might be used, but to be honest, in the industry, nobody use address, right? Because a trick here is the primary key should be an integer value. It should not be a string value. Okay, just keep that in mind. So once again, you repeat the step that you did for student. You would introduce a new column. So you would now actually do first normalization form for your table school. So your table school now will become something like this, where you have school ID. And let's just say 1, right? This record, because you already have this record down here, is the exact same record as the one above. So you can go ahead and delete it. Okay, you only need one ID per school. You don't want to have two different ID representing the same thing. Because what is school 1 and school 2? School 1 and school 2 are the same thing. Both are KSU, both have all exact attributes. So you don't want duplicate data. The whole point of primary key is so you can remove duplicate data. So now this is my data, right? My data go from one big giant table called student that has both student and school information. I went ahead, cleaned up the table so that each attribute has its own column. I introduced a primary key. In my second normalization form, I separate student and school into two different tables. And for table school, now I need to identify the primary key that would define table school so that I can have it in first normalization form. Right? So now school ID is my primary key and it become this form now is my first normalization form. Okay? Hopefully you guys all follow me, okay? If not, just send me an email. I can explain it again. Okay? Now, if I look at my table student, and let's just make sure you guys know this is second normalization form. I will go ahead and highlight this whole row in yellow. So each time you see that you know this whole piece belongs to the first normalization, this whole piece belongs to second normalization. Now what I have is table student and table school. What did I lose? What did I lose in my original ER diagram? I lost this relationship. So if I ask you, hey, give me the student and the school that the student go to, how are you going to join these two data together? All right, which now this is where foreign key come in. So in table student, what would change now is that you would introduce a foreign key, which is gonna be your school ID. Foreign key, or sometimes it's just called FK. It's not the F word, okay? All right. So now you look. Initially, the data has both NIC go to KSU. So when you look into table school, which ID represents KSU, right? Which is ID 1. So you would put 1 here, right? And that's it, folks. That's how you do your second normalization form. So once again, first normalization form, it's very simple. Taking the initial data after you convert it and break them out so that you have primary key. Second normalization form is to break this data because if not, then are you just gonna have ton 200 columns here for one table? No, right? What you would have is separate table with dedicated primary key that can uniquely identify the record in that table, and then you would have foreign key so that you can join the table together. In this case, you would join student because usually you talk about student go to school, so school would be the foreign key in the student table. Make sense? Okay, I heard someone say yes, so thank you. I'm just joking. All right, so now lastly, what you could also do here if you really want to continue doing this, then in your table school, you see how you have school address and school major. You can now create different table just to store school address and then give each unique address and ID if you want to. But usually people won't do that, right? Because one school usually only have one address. In here, school major, it has multiple major. Each major you could argue that should have its own ID. So you can have a table that say major ID and then major name. And what you would do is you would then map the school to each of those school major. right? You would create what is known as the mapping table. So that's what we would do for third normalization form. Third normalization form. Here we go. Once again, highlight this so you know this is third, and I'm gonna copy those two tables because they are in their final form now. Okay, so I would copy them here so you know. Okay. All right. Table school. Okay. So third normalization form essentially states that a primary key must fully define all columns in the table, and non-key column must not depend on any other key. In this case, your non-key column is your school major, right? Because school major, there's so many major, you're not gonna have this many value in it. What you would like to do is that you would make a table for school major. So make a table for school major. Table school major. Let me just write it. What you would have is, I'm just gonna go ahead and make it in first normalization form, which means I give it a major ID and then major name. Right, so I have biology, I have chemistry, I have computer science, and I have software engineer. And then my major ID, I just give it a unique ID, right? So I have 4 major in this school. Now, in my school table, right, what I would do is I can just simply change this to be school major foreign key, right? Hopefully you guys now all know it. I'm gonna call school major ID. One problem here is if I do this, then I would have 4 a very similar record, right? Major 4. But this, if I do this, this will have a violation called primary key violation, because a primary key should not repeat. But in this case, this primary key repeated 4 times. Since it's the same school but they just have different major, that's why the major ID, which is a foreign key to table major, right? That major ID 1 would map to biology, major ID 2 would map to chemistry. But if I do this, then I have a primary key violation. So what people usually do is they will create a separate mapping table, and that's their third normalization. Now I would leave this here. So what you would do first is you break this out. This is still your school table, but you will no longer have these value. Oh, that sucked. I gotta delete the whole column, okay? Delete. But if I do this, then that's not correct, right? If I delete everything, then now I leave it one record. What you do is go ahead and delete this whole column. So this table just won't have any foreign key. Okay. Now, so how do I then map major to my school? You have to introduce one more table, and that is your mapping table. Okay. So in the new table, what people usually do is they would just call it mapping table. In this case, they would call it the school major table. So this, let me just call it table majors. And so you know what major you have, and here would be school major table. And this simply will serve as your mapping table. In this mapping table, you will not define, you can define the primary key as well. But the first thing that you have to define is, first of all, what's your school ID and what's your major ID. You have school ID 1, major ID 1, 2, 3, 4, and it still map to the same school ID, alright? And you would give this a primary key. I'm just gonna call it school major ID. Okay, and this is your primary key for this table. Every table should have a primary key. This ID would be your foreign key to school. Major ID would be your foreign key to major. Then you have 1, 2, 3, 4. I'm just giving it random number, okay? 1, 2, 3, 4. So this is how you do third normalization form, right? This probably will confuse you, but it's okay. It takes some practice to get used to. And once you start actually database design, you will understand this more in depth. I promise you, right? But let's take a look again. Third normalization form. At this point, I already have two separate tables, school and student. Each of my table has primary key. My student table has a foreign key that allow me to know the school that these students go to. But now for third normalization form, I have opportunity to improve how the major is stored in my table school. So what I did was I removed that column school major all together. I make a new table called table major, and I give a unique primary key to each of the major in table major. The reason why I cannot create foreign key for major in my school table is because this is the same school. So if I do this, I will have a primary key violation because it would be school ID 1, 1, 1, 1, but it will still point to, just major ID 1, 2, 3, 4. The problem is the primary key cannot be repeated. If it's repeated, you have a primary key violation, right? Which is right here. This will cause primary key violation. I will highlight this in red and I will say primary key violation, okay? Which is why you need to create a mapping table. And in that mapping table, you use the same technique. You give it a unique primary key column, and each primary key column would just map the school to the major. So in this case, your school ID could be foreign key. Foreign key can be repeated, right? So foreign key school ID 1 map to major ID 1. That means KSU will have major biology. KSU has major chemistry. KSU has major computer science. KSU has major software engineer. Each of those major relationship to the school is represented by one primary key. The primary key are also not repeated. They are all different number. And that's it. Okay, so that's how you do first normalization, second normalization, and third normalization in order to help you out. Okay, what I would do is I will give you guys a table that has to do with hospital and staff or whatever. Go ahead, you don't have to worry about ER diagram, you don't have to worry about join anything. Go ahead and do first normalization in this format, second normalization, and third normalization, and turn that in. Alright, that's all. Thank you very much, class. See you guys.